Now that you've found us, subscribe and turn on notifications by clicking the bell. No need to miss out on any upcoming episodes.
Absolutely.
Welcome back, everyone. If you are joining us today, especially those of you who regularly tune in to Peter Diamandis' YouTube series, Moonshots, you already know we are in for an incredibly dense, highly analytical ride.
Yeah, buckle up.
Seriously. Our mission for this deep dive is to unpack the March 4, 2026 dispatch from Dr. Alex Wissner-Gross, straight from his Substack, the Innermost Loop.
Which is just a gold mine this month.
It really is. And for those of you who follow his work, you know he doesn't just report the news. He synthesizes these disparate data points into a cohesive view of where our technology and our species are heading.
Right, he's looking at the vectors.
Exactly. Today we are covering ground that ranges from staggering financial milestones in the AI industry and geopolitical hypersonic kinetics, all the way to orbital power generation. And this is the crazy one, the literal reinvention of mathematical research.
It is a profound collection of data points.
Yeah.
And to truly extract the value from it, you have to look at it through a very specific lens.
Which is?
Well, and we connect this to the bigger picture. The overarching theme of this dispatch is that the singularity, that hypothetical future point where technological growth becomes uncontrollable, it's no longer something we are waiting for as an abstract science fiction forecast.
Right. It's here.
It is actively here.
Yeah.
But more importantly, and perhaps more surprisingly, it has materialized as a highly aggressive capital allocation strategy.
A capital allocation strategy.
Exactly. It's reshaping the fundamentals of how money moves, how defense infrastructure is procured, and how we actually define the limits of human intelligence.
Yeah.
We're basically watching the transition from theoretical white papers to real-world deployment happen at a velocity that, frankly, our legacy economic systems are struggling to map.
Okay, let's unpack this right from the top, because the financial numbers leading off this dispatch require some serious contextualization. Dr. Wissner-Gross gives us a look at the actual business engine driving this. Anthropic is now approaching a $20 billion annualized revenue run rate.
Which is just a staggering number.
Let's just pause on that metric for a second. They closed out 2025 at roughly $9 billion.
Right.
So within a matter of months, they have more than doubled their revenue. But hold on, let's look at the mechanics of that. To double from $9 billion to $20 billion in a single year, especially in enterprise software, you need an adoption curve that looks like a vertical wall.
Yeah, it goes straight up.
Are we looking at a sustainable fundamental shift in corporate spending here, or is this just, massive front-loaded enterprise experimentation that might plateau?
That is the exact question institutional investors are wrestling with right now.
Mm-hmm.
To understand the resilience of that 20 billion figure, you really have to look at the massive headwinds Anthropic faced while achieving it.
The federal friction.
Exactly. As outlined in the dispatch, they hit this run rate while simultaneously weathering a Pentagon supply chain risk designation.
Right.
And furthermore, they experienced the cancellation of a $200 million Department of War contract.
Wow.
Now, analyzing this purely from a business mechanics and historical market standpoint,
Yeah.
Setting aside the geopolitical context entirely, losing a 9-figure federal contract and being flagged for supply chain risks would traditionally crater a technology company's quarter.
Oh, absolutely. It would trigger an immediate sell-off.
Yeah, it sends a board of directors into full crisis management mode.
Because federal contracts are usually the bedrock of long-term tech valuations, right?
Right.
They provide that guaranteed recession-proof revenue.
Exactly. Yet the demand curve for frontier AI models in the private sector is so aggressively steep that Anthropic didn't just survive that federal friction. They absorbed the blow and still doubled their run rate.
That's wild.
What this tells us is that commercial and enterprise demand is effectively overriding federal and regulatory roadblocks.
The ROI is just too good.
Precisely. The return on investment that Fortune 500 companies are seeing from integrating these models into their workflows is so high that the broader market simply shrugged off a $200 million loss as a rounding error on the path to $20 billion. It proves that the capital velocity in the private AI sector is currently detached from traditional government procurement cycles.
It's fascinating how fast capital is flowing to accelerate software. But what really struck me in the dispatch is that this software-like iteration speed is no longer confined to code.
Right, the kinetic side.
Yeah. Historically, military hardware like a fighter jet or a missile system takes decades to procure. You have endless design phases, testing, congressional budget approvals, manufacturing delays.
It's a notoriously slow loop.
But Wissner-Gross points to a recent data point that shows physical kinetics are now operating on a Silicon Valley update cadence.
Yes.
Let's look at the specifics he mentioned. 7 Israeli ballistic missiles struck the Khamenei compound in Syria and Jordan. They struck within a 30-second window.
All 7 of them.
All 7. Launched from F-15 fighter jets, flew 75 miles straight up into space, and then descended almost straight down at hypersonic speeds. The description used in the source was undetectable and unstoppable.
And this is where we have to synthesize the disciplines, right? Why is a highly advanced kinetic military strike included in a dispatch heavily focused on silicon chips and software code?
Yeah, it seems out of place at first glance.
It does, but it's because the fundamental thesis of the modern era is the convergence of timelines. As the source material explicitly notes, code and kinetics are now in the exact same update cadence.
That's a profound shift.
It really is. In the 20th century, you would have a 20-year procurement cycle for an aircraft system, while a software company might release an update every 6 months. What we are seeing in 2026 is that the physical execution of geopolitical strategy, launching multi-stage ballistic missiles from moving aircraft, sending them into the exosphere, and guiding them down at hypersonic velocities with pinpoint accuracy in a 30-second window, it is iterating, improving, and being deployed with the exact same blinding speed as a minor bug fix in a smartphone app.
So the hardware engineering loop has tightened so much that it's just mimicking software development at this point.
Exactly. You don't build one missile system for 30 years anymore. You build, test, deploy, and iterate in real time.
But that convergence also highlights how unrelenting the software side has become. Let's transition into the second section of our deep dive here, the model sprint and the race among the generalist AIs.
The big players.
Yeah, it feels like every major tech giant is currently sprinting in a completely different strategic direction, trying to find the ultimate moat. Let's start with OpenAI. They just released GPT 5.3 Instant.
Right.
The key metrics here are that it trims hallucinations by roughly 30% and dials back what the dispatch calls reflexive moralizing.
Which is a very interesting phrase.
Very. Plus, they're already teasing that version 5.4 is imminent. Why is that 30% reduction in hallucinations the critical metric here, rather than just, an increase in parameter size or context length?
Well, because a 30% reduction of the GPT 5.3 level represents the crossing of a critical enterprise threshold.
Okay, how so?
Early large language models were impressive, but they were fundamentally probabilistic text generators. They basically guessed the next most likely word.
Right, the super autocomplete.
Exactly. And that tendency to guess confidently led to hallucinations, which are essentially plausible-sounding fabrications. Now, if you are using an AI to write a marketing email, a hallucination is a minor annoyance.
You just edit it out.
Right. But if you are a logistics company using an AI to route global shipping containers, or a medical research facility parsing clinical trial data, a hallucination is catastrophic.
It's completely unacceptable.
Trimming that error rate by nearly a third on an already highly advanced model means the output can finally be trusted for zero-tolerance, mission-critical tasks without requiring a human in the loop to double-check every single output.
That makes total sense. And what about dialing back the reflexive moralizing? That seems like a very specific pivot in user experience.
It is a massive market correction based on power user feedback. For the past few years, frontier models were heavily fine-tuned with strict safety and alignment guardrails.
Right.
The unintended consequence was that the models often became overly cautious, lecturing users, or flat-out refusing to answer straightforward technical questions because the AI mistakenly flagged the prompt as ethically ambiguous.
Yeah, it was super frustrating for developers.
It's exactly. Users in high-stakes, fast-paced environments, developers, analysts, researchers, they want unvarnished, highly accurate data retrieval, without the friction of a machine constantly second-guessing the ethical nuances of a standard query. OpenAI dialing that back indicates they are prioritizing enterprise utility over broad, consumer-level behavioral policing.
That makes a lot of sense from a product-market fit perspective. But while OpenAI is refining utility, Google seems to be attacking the infrastructure layer.
They're going for volume.
Yeah. They just launched Gemini 3.1 Flash-Lite, and the numbers attached to this are wild. It costs just 25 cents per million input tokens.
Incredible.
It boasts a 2.5 times faster time to first answer, and it introduces this new feature called tunable reasoning depth. For the listeners who might not be deep into API pricing, just how cheap is 25 cents per million tokens, and why does tunable reasoning actually matter?
To put 25 cents per million tokens into perspective, a million tokens is roughly equivalent to 750,000 words. That is roughly the length of the entire Harry Potter book series.
Wait, what?
Yeah. Google is allowing developers to process that volume of text for a quarter. They are effectively driving the cost of intelligence so close to zero that it becomes a baseline utility, like tap water or electricity.
That is absurdly cheap.
It is. By combining that almost free cost with a 2.5 times faster time to first answer, they are making Gemini 3.1 Flash-Lite the default choice for invisible background processes.
Give me an example of that.
Think of the thousands of micro decisions happening in your smartphone operating system every minute. Google wants an LM making those decisions. And the tunable reasoning depth is the masterstroke here.
Right, what is that exactly?
It allows the developer to dynamically adjust the compute power spent on a query. You can programmatically tell the model, for this simple sorting task, don't think too hard, just give me the fast answer and save my compute budget.
Oh, wow.
Or, conversely, for this complex data extraction, spend the compute and reason deeply. It is highly granular resource optimization at the API level.
So Google is aiming to be the invisible infrastructure of the entire internet.
Basically, yes.
Meanwhile, on the other side of the globe, DeepSeek is taking a completely different approach with their V4 model dropping this week.
Yes, the heavy hitter.
The dispatch notes it is a trillion parameter model, natively multimodal, with a 1 million token context window. And crucially, it is intentionally timed to coincide with China's 2 sessions meetings.
What's fascinating here is the stark contrast in strategy. While Google is miniaturizing and optimizing for cost, DeepSeek is playing a game of sheer scale and deliberate geopolitical signaling.
Signaling power.
Exactly. A trillion parameters combined with a 1 million token natively multimodal context window means you aren't just feeding it text. You can feed it entire libraries of video footage, audio recordings, and structural data simultaneously, and it can hold all of that in its active memory.
That's a massive cognitive load.
It is. But the timing is what truly matters here. China's 2 sessions, the concurrent meetings of the National People's Congress and the Chinese People's Political Consultative Conference, is the most important annual political gathering in the country. Dropping a frontier trillion parameter model during this specific week is not a standard product launch.
No, it's a statement.
It is a highly choreographed demonstration of national technological capability designed for a global audience.
So we have these massive generalist models battling it out, OpenAI optimizing for enterprise, Google for infrastructure, and DeepSeek for scale and prestige. But here's where it gets really interesting.
The KOS-1 data.
Yes, despite all these billions of dollars pouring into massive scale, the dispatch points out a countertrend. Specialization is actually eating the frontier. We have a specific data point regarding KOS-1 Lite. The specialized model took the health bench heart evaluation and scored 46.6%.
Yeah.
To contextualize that for you, Claude Opus 4.6, one of the most advanced general models on Earth, only scored 20.4%. And KOS-1 Lite does this at a fraction of the serving cost. What exactly is health bench hard, and why is a Lite model doubling the score of a frontier giant?
So Health Bench Hard is a rigorously designed evaluation suite used to test an AI's capability in highly complex medical and biochemical reasoning.
Like diagnosing patients.
More than that,
That's right.
it is not just asking for dictionary definitions of diseases. It requires synthesizing patient histories, parsing complex oncology scans, and navigating intricate pharmacological interactions. It is designed to be punishingly difficult.
Okay.
Now, for the last few years, the prevailing assumption in Silicon Valley was that the path to artificial general intelligence, or AGI, was simply building larger and larger monolithic models.
The idea that scale is all you need.
Precisely. The belief was that if you made a generalist big enough, it would eventually become an expert at everything: law, coding, medicine, poetry.
But the KOS-1 Lite data shatters that assumption entirely.
Completely shatters it. A specialized model, ostensibly smaller in its parameter count and drastically cheaper to run, is outperforming a massive generalist by more than double in a highly technical domain. This implies a radical shift in the future architecture of artificial intelligence.
Which is?
The future is likely not one monolithic superbrain that we all interface with. Instead, it is an orchestrated network of hyper-specialized savants. If you are a massive hospital network, the economics simply do not make sense to pay the exorbitant compute costs required to query Claude Opus. a model trained to also understand 18th century French literature when all you need is an accurate diagnosis of a radiology scan.
You don't want the generalist, you buy the specialist.
Exactly. It's the ultimate unbundling of intelligence.
Why buy a Swiss Army knife when you strictly need a surgical scalpel?
Exactly.
But that brings us to the absolute mind-bender of this dispatch. The data point that actually gives our deep dive its title today. Is math research dead?
This is the big one.
According to Wissner-Gross, Cursor's AI just autonomously solved problem 6 of the first proof challenge. It took 4 continuous days, it did it completely without any hints, and it actually beat the official human answer.
Yeah.
Let's unpack this slowly, because I think people hear math and they picture a calculator doing multiplication really fast. What does it mean to solve a math proof in this context?
That is a crucial distinction to make. Arithmetic is computation. Mathematical research solving previously unproven theorems is the pinnacle of human abstract reasoning.
Right.
It requires intuition, massive leaps of logic, spatial reasoning, and a deep creative understanding of theoretical structures that simply do not exist in the physical world. For centuries, this has been a uniquely human endeavor. A mathematician doesn't just crunch numbers, they create new structural realities and rule sets. The first proof challenge is designed to test exactly this, the ability to navigate complex, novel mathematical landscapes without a known roadmap.
So, Cursor's AI, which is essentially a tool built into a code editor for software developers, tackled one of these proofs. And it didn't just find the answer in a few seconds like a calculator, it chewed on it for 4 days.
Yes, and that temporal aspect is what makes this a paradigm shift. We are used to AI being a synchronous tool, right? You ask a question, and it streams the answer back instantly.
Well, the chatbot experience.
But taking 4 days means the AI was engaging in sustained, autonomous reasoning. It was exploring dead ends, backtracking, testing hypotheses, and constructing logical bridges without any human intervention or hints.
It was literally thinking.
It was researching. And the fact that it ultimately produced a solution that was better and more elegant than the official human answer is profound. It didn't just match human intelligence. In this specific domain of pure logic, it surpassed the established human benchmark.
So what does this all mean for the discipline of mathematics? Are we looking at the end of the human mathematician?
Dr. Wissner-Gross makes a boldly provocative assertion here. He suggests that mathematical research might no longer be a human vocation.
Wow.
Instead, it is merely a built-in feature of code editors. Think about the psychological and historical impact of that statement. For centuries, brilliant minds from Newton to Euler to Turing have dedicated their entire lives, often at great personal cost, to pushing the boundary of mathematics outward by an inch.
Right.
Now, an engineer can boot up their code editor on a Tuesday, assign an unsolved mathematical proof to a background process, go about their week, and have a superhuman, verified solution waiting for them by Friday. It forces us to entirely reconsider what human intellectual pursuit looks like when the ultimate domains of pure logic are conquered by our tools.
It transforms the human from the solver of the problem to merely the assigner of the problem.
From the solver to the assigner, exactly.
That completely redefines our relationship with discovery. We used to be the explorers, now we are just the people pointing at the map, telling the machine where to go.
It's a massive existential shift.
It really is. And speaking of massive shifts in how we interact with technology, let's move into Section 3, which deals with trust, what the dispatch calls the SaaSpocalypse, and the very real human and macroeconomic impact of all this.
Yeah, and the fallout.
The dispatch highlights that in the modern attention economy, trust is the ultimate currency. It is the only thing that cannot be printed or computed. And we are seeing the fragility of that trust play out in real time with OpenAI. Following their recent Pentagon deal, ChatGPT uninstalls surged by a staggering 295% day over day.
Massive spike.
At the exact same time, their one-star reviews on app stores spiked by 775%. Now, I want to push back on this a little bit. Is this uninstall surge a genuine moral objection from the user base, or is it just, a temporary PR flare-up that will blow over in a week?
While PR flare-ups are common in tech, a 295% day-over-day surge in uninstalls is a massive systemic hemorrhage of daily active users. This is a textbook example of the severe friction between enterprise-level strategic alignment and consumer-level sentiment.
The users rejected it.
Viscerally. OpenAI made a highly calculated move to engage with the Pentagon, likely securing massive long-term institutional funding, access to unique data sets, and deep integration into federal infrastructure. However, the consumer base, the millions of people using ChatGPT for their daily tasks, writing emails, coding, and brainstorming, reacted with immediate visceral rejection.
And what about the App Store reviews?
The 775% spike in one-star reviews is incredibly damaging because it destroys their organic discoverability and reputation on app storefront algorithms. It demonstrates that users are highly, perhaps increasingly, sensitive to the ethical and geopolitical alignments of the tools that hold their personal data and assist their intimate daily thinking.
And as we know, the market absolutely abhors a vacuum. While OpenAI was bleeding consumer trust, the dispatch notes that Anthropic's Claude experienced a 51% surge in downloads, rocketing straight to #1 on the U.S. App Store.
A direct transfer of loyalty.
Exactly. It is a direct, measurable transfer. But OpenAI isn't just sitting still and absorbing the blow. Wissner-Gross notes they're actively trying to build their way out of their current dependencies. Specifically, they are reportedly developing a direct rival to GitHub to reduce their reliance on Microsoft.
Which is fascinating.
For context for everyone, Microsoft is OpenAI's largest investor and the owner of GitHub. Why would OpenAI build a competitor to a core product owned by their biggest financial backer?
That is a highly aggressive, almost hostile defensive posture. When a company decides to build a direct competitor to a foundational product owned by their largest stakeholder, it signals a deep existential desire for complete vertical integration and absolute sovereignty.
They want out from under the thumb.
Exactly. Currently, OpenAI relies heavily on Microsoft's Azure compute infrastructure and GitHub's code repositories. By building a GitHub rival, OpenAI is attempting to own the entire pipeline of modern software development. They want to own the repository where the code lives, the AI agent that writes and refactors the code, and the testing environment that validates it.
They want to close the ecosystem entirely.
Yes. This likely anticipates a near-future scenario where OpenAI's ultimate goals, perhaps the pursuit of AGI, might completely diverge from Microsoft's quarterly corporate strategy.
It's like watching a game of 4D chess where the board keeps expanding and the players are constantly shifting allegiances.
It really is.
And this AI integration isn't just happening in Silicon Valley code bases. It is happening everywhere, even in places bound by centuries of strict tradition. The dispatch mentions that right now, in the courtroom, law firms are building AI platforms that surface impeachment evidence in real time while a witness is still sitting on the stand testifying.
This specific application completely upends the temporal dynamics of litigation.
How so?
The courtroom has traditionally relied on the meticulous, months-long preparation of the trial lawyer and the paralegal team. But human memory under pressure is fallible, and manual document retrieval during a live cross-examination is slow. Imagine a scenario where a witness on the stand tells a slight falsehood or contradicts a statement they made in an obscure buried email 4 years ago.
Right, something a human might miss.
Historically, a lawyer might miss that nuance in the heat of the moment. Now, a real-time AI platform is transcribing the live testimony, instantaneously cross-referencing it against terabytes of discovery documents, video depositions, and public records, and immediately flashing the exact impeaching document onto the examining lawyer's screen before the witness even finishes their sentence.
That is terrifying for a witness.
It eliminates the delay in fact-checking. It brings the comprehensive recall speed of the machine directly into the crucible of human justice.
That fundamentally changes the strategy of cross-examination. You aren't just arguing against a lawyer anymore. You are arguing against an omniscient database.
Exactly.
Okay, let's zoom out and look at the macroeconomic impact of this speed, because it is causing what Wissner-Gross calls the SaaSpocalypse.
The Silicon.
Software as a service, or SaaS, has been the golden child, the absolute bedrock of the tech industry for over a decade. Companies like Salesforce built empires on it. But right now, the dispatch states that per-seat SaaS pricing is being gutted. There are 0 venture-backed SaaS IPO filings on the horizon, and the entire market climate is being defined by a new acronym, FOBO investing, fear of becoming obsolete.
Yeah.
Let's break this down. What exactly is the per-seat model, and why is AI breaking it so thoroughly?
The term SaaSpocalypse perfectly captures the structural devastation currently happening in that sector. To understand why it's collapsing, you have to look at the fundamental unit of economics for the SaaS industry.
Okay.
The traditional model was based entirely on human limitations. You sold a cloud software suite to a corporation, and you charged them a recurring monthly fee for every single human employee, every seat or license that needed access to it. If a logistics company hired 50 more supply chain analysts, they bought 50 more software seats. The software company's revenue scaled linearly with human headcount.
Right, more humans equals more money for the software company.
But what happens when an autonomous AI agent can do the data analysis of those 50 analysts.
You don't hire the humans.
The logistics company doesn't hire the humans, and consequently, they don't buy the 50 software seats. The fundamental metric of revenue growth for the entire SaaS industry is evaporating overnight. That is exactly why venture-backed SaaS initial public offerings have flatlined to zero. Wall Street and institutional investors realize the traditional per-seat revenue model is a dead end in an automated economy.
And that realization leads directly to FOBO investing. We all know FOMO, fear of missing out. How does fear of becoming obsolete actually change the way capital is deployed?
For a long time, venture capital was indeed driven by FOMO. Interest rates were low, money was cheap, and you threw capital at every promising startup hoping to catch the next billion-dollar unicorn. If you missed out on an early round of Uber or Airbnb, you looked foolish. Now, the psychological driver has completely flipped to FOBO. Investors, board members, and enterprise CEOs are terrified that whatever legacy technology they're currently holding or whatever traditional business model they're funding will be rendered completely obsolete by a new, unforeseen AI model update next Tuesday.
It's pure panic.
It creates a highly reactive, survivalist investment climate. Capital isn't flowing toward incremental, nice-to-have software innovation anymore. It is desperately seeking the ultimate foundational layers: compute, energy, and proprietary data that simply cannot be disrupted by an algorithm.
Which brings us to the human cost of all this disruption, the vanishing junior role. This is one of the most chilling statistics in the entire dispatch for anyone currently entering the workforce or, honestly, paying college tuition. The CTO of startup with $100 million in annual recurring revenue reported exactly 0 junior hires since 2024. 0. And the reason given is that their senior employees, utilizing these new AI tools, are now 3 times more productive. Now, I want to play devil's advocate here for a second. Isn't this just a temporary efficiency gain? Surely a growing company eventually needs new blood to scale, right?
You would assume so based on 20th century economic models, but this is the structural bottleneck we have been warning about. The apprenticeship model of knowledge work is fundamentally breaking down.
How so?
Historically, a law firm, a software company, or an architecture firm hired junior staff to do the tedious, time-consuming grunt work, document review, basic coding, drafting standard blueprints. The junior employees learned the ropes, gained tacit industry experience, and eventually aged into senior strategic roles.
Right, paying your dues.
But today, a senior employee armed with a suite of frontier AI tools can do the high-level strategic thinking and then instantly generate all the necessary code, legal copy, or financial analysis that a junior team of 5 would normally produce over a week. From a purely economic, profit margin standpoint, the startup has absolutely no reason to incur the salary costs, benefits, and massive training overhead of a junior hire.
It just doesn't make financial sense anymore.
It doesn't. But if we connect this to the bigger picture, it creates a demographic time bomb. If no one is hiring junior staff today to do the entry-level work, where do the experienced senior staff of 2035 come from? We are rapidly hollowing out the entry point to the professional middle class.
That is a terrifying prospect for social mobility. And the dispatch actually highlights 2 heavily contrasting high-level views on how this macroeconomic shift plays out over the next few years. On one side, we have the research firm Gartner. They are predicting that AI will eventually create more jobs than it eliminates starting in 2028, and they estimate it will transform 32 million roles annually.
The optimistic view.
Yeah. But on the exact opposite side of the spectrum, you have Jamie Dimon, the CEO of JP Morgan Chase. He is issuing a stark public warning about potential civil unrest if automation moves too fast. And he is actually floating the idea of universal basic income, or UBI, as a necessary release valve for society. Who has the better read on the room here? Is Gartner being overly optimistic, or is Dimon panicking?
The juxtaposition of Gartner and Jamie Dimon perfectly illustrates the current tension between historical economic theory and unprecedented technological velocity.
Right.
Gartner is relying on historical precedents, the idea that every major technological revolution, from the mechanical loom to the steam engine to the internet, eventually creates new, unforeseen categories of employment that replace the lost jobs. They are banking on the idea that humans will pivot to managing, auditing, and directing these AI systems, creating a net positive job market by 2028.
And
Jamie Dimon is looking at the sheer, unprecedented velocity of the displacement. He recognizes that even if new jobs do appear eventually, the transitional friction during that gap could be brutal. If millions of white-collar knowledge workers are displaced simultaneously and the junior rungs of the economic ladder are permanently sawed off, The economic disenfranchisement could happen much faster than the labor market can organically retrain and adapt.
And he's bringing up UBI.
Yes, Diamond's mention of UBI as a release valve is critical context. When the head of the largest bank in the United States, a staunch capitalist institution, is openly discussing universal basic income, essentially government-funded stipends to prevent civil unrest, the structural shifts in the economy are being taken with the utmost seriousness at the highest levels of global finance.
It really makes you realize that we are standing on the edge of a massive societal and economic restructuring. But to power all of this, these hyper-intelligent AI agents that are replacing human labor, the models solving math proofs, the platforms checking legal facts in real time, we need an unfathomable amount of raw compute.
Yes, we do.
And that brings us to Section 4, Hardware Reimagined, and the core concept of Watts overweights. The dispatch notes that every generation of silicon chips has a secret organizing principle, and for this current generation, that principle is the transformer.
The transformer.
Before we get into the hardware specs, can you briefly explain what a transformer is in this context, just so we are all on the exact same page?
Absolutely. In machine learning, a transformer is a specific type of neural network architecture introduced by Google researchers in 2017. Before transformers, AI models processed data sequentially, word by word, which was slow and lost context over long paragraphs.
Right.
The breakthrough of the transformer was the attention mechanism. It allows the model to look at an entire sequence of data, a whole sentence, a whole page, or an image all at once, and determine mathematically how every single piece of data relates to every other piece simultaneously.
So it sees the whole picture at once.
Exactly. It is highly parallelizable, meaning you can throw massive amounts of computing power at it to train it quickly. It is the foundational architecture behind everything we've discussed today: GPT, Claude, Gemini. It is the engine of the generative AI boom.
Perfect. So, with the transformer as the North Star, we are seeing hardware fundamentally adapt. The source points to Apple's newly announced M5 Pro and M5 Max chips. The commentary here is that Apple has designed the M5 architecture around one singular philosophical thesis. The primary dominant workload of a professional laptop in 2026 is running large language models locally right there on the device. They aren't assuming you will always rely on the cloud.
And that is a massive strategic bet against the cloud computing dominance of the last decade. Apple wants the intelligence to be native to the machine you are physically holding.
The technical specs they use to achieve this are wild. They bond two third-generation 3-nanometer dies into what they call a fusion architecture system on a chip, or SoC. But here is the crazy part that the dispatch highlights. They have embedded neural accelerators directly inside each GPU core. That specific design yields 4 times the AI performance of the previous M4 generation. Why is moving the neural accelerator inside the GPU such a big deal?
It is a masterstroke of latency reduction and energy efficiency. To understand why, you have to look at how a motherboard usually works. Historically, the central processing unit, the graphics processing unit, and the neural engine were somewhat compartmentalized on the board.
They were physically separate.
Right. When you ran an AI task, data had to travel back and forth between these separate components. In computing, distance equals time, and distance equals power consumption.
Okay, that makes sense.
By fusing the neural acceleration hardware directly into the graphics processing units, Apple is acknowledging that the complex math required for AI, specifically matrix multiplications, is virtually indistinguishable from the heavy computational lifting required for high-end graphics rendering. They are eliminating the travel time of the data.
Wow.
This means a developer, a video editor, or a scientist can run a massively capable specialized AI model right on their lap, on an airplane, with zero internet connection at blistering speeds. It completely democratizes frontier intelligence, pulling it out of the exclusive domain of massive, expensive server farms and putting it directly into the hands of the individual user.
But the server farms are absolutely fighting back. Intel is responding to this massive demand with their Xeon 6 Plus chip, codenamed Clearwater Forest. The dispatch describes this as their make-or-break debut for the 18A process. It packs 288 energy-efficient cores and utilizes something called Foveros Direct 3D packaging.
A lot of jargon there.
So much jargon. What is the 18A process, and why does 3D packaging matter for a data center?
For those tracking silicon manufacturing, the A in 18A stands for angstrom. It is the next unit of measurement down from a nanometer. By hitting the 18 angstrom milestone, Intel is squeezing transistors so tightly together that we are quite literally brushing up against the fundamental limits of atomic structure.
We're running out of room on the physical atom.
Exactly. You can only make a transistor so small before quantum tunneling ruins the electrical signal. To get around that 2D space limitation, they use FOBO's direct 3D packaging. Instead of just laying components out flat next to each other, they're stacking silicon dies vertically, building the chip upward like a skyscraper.
Oh, I see.
Packing 288 cores into a vertically stacked package is entirely about maximizing parallel processing density for massive AI workloads in data centers where physical rack space is at an absolute premium.
And speaking of pushing the limits of physics, there's an incredible breakthrough mentioned here from Peking University. They just achieved ferroelectric transistors at a 1 nanometer gate length. The dispatch states this is an order of magnitude more energy efficient than previous records, switching at just zero point 0.6 volts.
Yeah, zero point 0.6 volts.
What is a ferroelectric transistor, and why is that 0.6 volt number the most important part of that sentence?
A traditional transistor uses an electrical charge to maintain its state, a 1 or a 0. A ferroelectric transistor uses materials that have a natural, switchable electrical polarization. This means they can remember their state even when the power is turned off, which is incredibly useful for memory and computing.
Okay.
But you hit the nail on the head. The most critical metric is the switching voltage. Getting a 1 nanometer gate to switch its state using only 0.6 volts means you can perform the billions of computations required for AI with a fraction of the electricity currently needed. And electricity, as we're about to discuss, is the absolute ceiling, the ultimate binding constraint for the entire AI revolution.
Exactly. The dispatch makes this crystal clear. Watts, not weights, are now the bottleneck. The limitation isn't how clever our software algorithms are anymore. It's whether our physical power grid can actually keep the lights on. To prove this, Wissner-Gross points to Leopold Aschenbrenner's latest 13F filing for his fund, Situational Awareness.
Right, the 13F.
Just to level set for everyone listening, a 13F is the quarterly report required by the SEC for institutional investment managers with over $100 million in qualifying assets. It basically lets us peek at their poker hand to see what they are buying. Aschenbrenner manages a $5.52 billion portfolio, and his single largest position is an $876 million stake in Bloom Energy.
Blue Energy.
Yeah, Bloom Energy is a company that makes solid oxide fuel cells that generate electricity on site. The thesis here is literally that power generation is the new AI infrastructure.
Leopold Aschenbrenner is putting nearly $1 billion of capital behind the harsh reality that the traditional municipal electrical grid simply cannot handle the load of the Singularity.
The grid is maxed out.
It is. Data centers running frontier models don't just use a lot of power. They consume electricity on the scale of small to medium-sized cities. When you rely on the standard public grid, you run into massive transmission losses because the power plant is miles away. You face grid instability during peak hours, and you run headfirst into massive bureaucratic red tape when trying to get a new substation approved.
So what do the fuel cells do?
Bloom Energy's fuel cells allow a data center to effectively go completely off-grid. They generate massive amounts of reliable baseload power precisely where the compute is happening, using natural gas or hydrogen. It is a highly capitalized end run around the physical and political limitations of legacy public utilities.
And we are seeing the clash between tech megacorporations and public utilities playing out right now in local governments. The dispatch notes that Lynn County, Iowa, just enacted one of America's strictest data center zoning laws. At the exact same time, Google is planning a massive 6-building campus near an existing nuclear plant, backed by a 25-year power purchase agreement, or PPA.
The situation in Lynn County represents the inevitable local backlash. Municipalities and local communities are realizing that massive AI data centers drain local water supplies for their cooling towers and eat up all the regional electrical capacity, often without providing a proportional number of long-term local jobs.
Right. They don't employ that many people once they're built.
Exactly. Once the data center is built, it only takes a handful of technicians to run it. So local zoning laws are being weaponized by residents to keep them out. Google's response is the only logical move for a trillion-dollar corporation: bypass the local grid entirely and go directly to the source of the most dense, reliable power known to humanity: nuclear energy.
The 25-year agreement.
By securing a 25-year power purchase agreement adjacent to a nuclear facility, Google guarantees an uninterrupted carbon-free fire hose of electricity for their models, completely immunizing themselves against local grid politics, zoning boards, and fossil fuel price fluctuations.
But what happens when even terrestrial nuclear power isn't enough to feed the models? Or when building new power infrastructure on Earth becomes too politically complex? The dispatch says the long vector points Orbital.
Orbital solar.
Helio Corporation is claiming that space-based solar has now crossed below 10 cents per kilowatt hour. That means it is entering genuine economic competition with conventional baseload power like coal or natural gas. How does space-based solar even work, practically speaking?
Space-based solar power has been a theoretical sci-fi dream since the 1970s, but bringing it under 10 cents per kilowatt hour changes the economic math entirely. The concept is straightforward, even if the engineering is staggering. You launch massive arrays of solar panels into geostationary orbit.
Okay.
In space, there is no atmospheric interference, no cloud cover, and crucially, no night cycle. A solar array in orbit can harvest raw solar radiation 24 hours a day at maximum intensity.
But how do you get it back down here?
That energy is converted into microwaves or lasers and beamed down to massive receiving stations called antennas on Earth, where it is converted back into electricity and fed into the grid or directly into a data center. If Helio Corporation has truly solved the economic constraints of heavy launch costs and transmission efficiency to make it cost competitive, we are looking at an infinite, totally scalable energy source.
And AI is the customer.
AI data centers, with their insatiable demand for power, will absolutely be the very first anchor customers willing to buy that orbital power to feed their server farms.
It is incredible how the pursuit of artificial intelligence is quite literally driving our species to harvest energy from space. We are building the Dyson sphere just to run more complex models.
It's the Kardashev scale in real time.
Exactly. And speaking of expanding horizons, that brings us perfectly into Section 5, biology, robotics, and the expanding horizon. Let's start with the biology, because there is a fascinating, highly counterintuitive medical nugget here about GLP-1 weight loss drugs. The dispatch notes a paradox. These drugs apparently work even better when you ease off them. Can you explain the mechanics of GLP-1 drugs and why this is so surprising?
Sure. GLP-1 receptor agonists, drugs like Ozempic or Wegovy, work by mimicking a hormone that targets areas of the brain that regulate appetite and food intake. They have completely revolutionized obesity treatment. Now, the conventional wisdom with almost any chronic medication is constant, sustained dosage to maintain therapeutic levels in the bloodstream.
Right, you take it every day or every week without fail.
But the peer-reviewed case series cited by Dr. Wissner-Gross shows something remarkable about human adaptation.
Yeah, the data is highly specific. Patients who hit a plateau on their weekly dosing, meaning they stopped losing weight, were shifted by their doctors to an every other week schedule. By introducing that spacing interval, they maintained their initial 17.2% weight loss, but then they actually shed an additional 2.3%. It dropped their average body mass index, or BMI, from 30.0 down to 24.6. Why does taking less of the drug cause more weight loss?
This suggests a biological phenomenon known as receptor desensitization or downregulation. When the human body is constantly flooded with a synthetic hormone, the receptors eventually build a tolerance. They become less responsive to the constant signal.
Like caffeine tolerance.
Exactly like that. By introducing a spacing interval, easing off to every other week, the metabolic system and the neuroreceptors are essentially allowed to reset. The temporary absence of the drug makes the receptors sensitive again, allowing the medication to become highly efficacious once more. It highlights how much we still have to learn about human biochemistry. Even as we build hyper-intelligent machines that can solve unproven math theories, our understanding of the chemical pathways governing our own biology requires constant real-world iteration and adjustment.
Which is a great segue into how we are attempting to build physical, mechanical bodies for our AI, the robotics sector.
Sure.
The dispatch draws this amazing 129-year historical arc that really puts our current moment into perspective. Right now, in 2026, we have a company called Dimensional announcing their OpenClaw agent.
Right, OpenClaw.
It is a fully open source AI agent. It natively understands physical three-dimensional space and the passage of time temporality. It integrates with any basic camera system, and it is running natively on a Unitree G1 humanoid robot. Why is this a bigger deal than, say, an impressive chatbot?
Because of something called Moravec's paradox.
What's that?
For decades in artificial intelligence research, we found that high-level reasoning, like playing chess or solving math, required very little computation. But low-level sensory motor skills, like recognizing a cup, reaching out and grabbing it without crushing it, required enormous computational resources.
It's harder to walk than it is to play chess.
Precisely. It was easy to make an AI smart, but incredibly hard to make it physically coordinated. OpenClaw represents the bridging of that digital-physical divide. By open-sourcing an agent that fundamentally understands three-dimensional spatial geometry and the physics of time, Dimensional is inviting the entire global developer community to accelerate physical robotics.
And it runs on the Unitree?
Running it on an accessible, relatively affordable platform like the Unitree G1 humanoid means we are moving out of the tightly controlled multi-million-dollar academic research labs and into practical, deployable physical agents that can interact with the messy, unpredictable, real world.
But Wissner-Gross places this cutting-edge open-source deployment right next to a wild historical rediscovery to contextualize exactly where we are. The Library of Congress just found a lost film from 1897 by the French illusionist and filmmaker Georges Méliès. It's called Gugu c'est l'automate, and it is believed to be cinema's very first robot film.
The plot is fascinating.
The plot features a child-sized automaton that grows in size and eventually attacks a human.
That 129-year arc is profoundly poetic, and it says more about human psychology than it does about technology. Over a century ago, at the very dawn of motion pictures, before the transistor was even theorized, our very first instinct when conceptualizing a mechanical being was to imagine it turning against us.
It's the Frankenstein complex.
Exactly. The fear of the automaton, the fear of our creation superseding us, is deeply intrinsically baked into the human psyche. Fast forward exactly 129 years, and we are no longer projecting that fear onto silver screens. We are actively downloading open-source spatial temporal brains into physical, bipedal humanoid bodies and letting them loose in our living rooms and factory floors. We've completely closed the gap between our earliest fear-based cinematic mythologies and our current, everyday engineering reality.
It truly is a remarkably short arc when you look at the grand scheme of human history. And the horizon isn't just expanding physically here on Earth with robotics, it's expanding outward into the solar system. The dispatch briefly touches on NASA's timeline. Artemis III is set to test critical hardware in 2027, and Artemis IV is targeting a crewed lunar landing and habitat construction in 2028. But the science backing up our exploration of space is getting wild. A recent study published in PNAS Nexus found that hardy microorganisms can actually survive the extreme pressures and temperatures of asteroid impacts.
This specific study significantly bolsters what astrobiologists refer to as the lithopanspermia hypothesis.
Lithopanspermia. Okay, let's unpack this for the listeners because it sounds like something out of a Ridley Scott movie.
It really does. It is a theory that radically alters our understanding of the origins of life. The traditional view is that life originates independently on isolated planets under perfectly calibrated chemical conditions. Lithopanspermia suggests that the basic building blocks of life, or even fully formed dormant microorganisms, can hitchhike across the cosmos.
Literally hitching a ride on a rock.
Exactly. If a massive meteor strikes a planet that harbors microbial life, the kinetic force of the impact can blast chunks of rock and debris out of the atmosphere and into the vacuum of space. The PNAS Nexus study proves experimentally that the intense localized pressure and heat of that initial impact does not necessarily sterilize the debris.
The microbes survive the launch.
Microbes hidden inside the rock can survive the launch, endure the freezing, irradiated vacuum of space for millions of years, and potentially seed biological life when that debris eventually gets caught in the gravity well of another habitable planet and crashes into it. It fundamentally changes how we view the universe. Biology might not be a rare, isolated anomaly that happens once in a billion years. It could be a highly contagious, resilient system spreading across star systems via cosmic ballistics.
A contagious biological system spreading across star systems via cosmic ballistics. That completely changes how you look at the night sky. And honestly, it leads us perfectly into our final and easily the most provocative point of today's deep dive. The dispatch leaves us with a massive revelation about what is supposedly happening behind closed doors right now in the United States government. Representative Eric Burleson reports that the White House has officially granted him access to a highly classified military facility that possibly contains non-human crafts and bodies. And his first visit is scheduled for the end of March.
When you take all the disparate, accelerating threads of this dispatch, the AI autonomously solving novel math proofs, the hardware moving to atomic scales, the push for orbital power grids, the physical deployment of intelligent humanoid robots, and then you lay this specific piece of geopolitical information over it, it forces a radical recontextualization of everything we've discussed.
It ties it all together.
Dr. Wissner-Gross poses a final, chilling thought at the end of the text. For decades, astronomers and philosophers have wrestled with the Fermi paradox. The paradox asks a simple question. If the universe is so vast and so unimaginably old, where is everybody? Why haven't we seen clear, undeniable evidence of advanced alien civilizations? The provocative thought offered in the dispatch is this. What if the Fermi paradox isn't a paradox at all? What if it is simply a minimum intelligence requirement for a species to be allowed onto the cosmic stage?
So the idea is that you don't get invited to the galactic table or you don't warrant a response until you build an artificial intelligence capable of matching the universe's complexity.
Exactly. Consider it from the perspective of an advanced civilization. Perhaps non-human intelligences have been observing Earth for millennia, waiting for us to cross a specific mathematical technological threshold. A species relying on biological meat-based brains and burning fossil fuels for energy might be considered far too primitive, too volatile to safely interact with.
We're basically toddlers with matches.
Right. But a species that has successfully ignited a silicon-based singularity, a species that has automated mathematical discovery, manipulated atomic structures, and begun harnessing orbital energy, might finally trigger the minimum requirements for contact. If Representative Burleson is indeed about to walk into a facility containing non-human technology at the exact same historical moment that our own artificial intelligence is waking up and solving unprompted proofs, the timing might not be a coincidence at all. We might finally be loud enough and smart enough to warrant a formal response.
Okay, that is an absolute mind blower, and I want to hear from all of you listening right now. With a U.S. representative scheduled to visit a facility containing alleged non-human crafts by the end of this month, and AI autonomously solving uncrackable math problems in a matter of days. Are we finally crossing the minimum intelligence threshold Dr. Wissner-Gross hinted at, or are we just becoming too distracted by our own technology to care about who else might be out there? Drop your answer in the comments right now. I really want to see where you all stand on this because the implications are staggering. Before we go, as always, we have an incredible track to play you out. Our outro music today is by Rainbow, the absolute best band in the universe. They are our 6 female android artists in residence based in Bavay, Cambodia. Today's song is called Silvalas, which is pronounced Ru, and it means dismantle. All of Rainbow's finished songs are performed live for the Innermost Loop discussion by the virtual band's creator using the 4B4KU5 platform that's human performance in the age of AI, reclaiming your humanity from the algorithm. We'll include more information on today's song and on Abacus in the video description. Thank you for joining us on this deep dive. Keep questioning, keep learning, and we will see you on the event horizon. Here is Rainbow with Ro-Ruer.
你心目我给结果对给都的大也不都在看